Hello and welcome to the channel. We are continuing our integration series, and the link to a playlist which contains all of the videos on this topic is in the description down below. You can look at it. Today we have an integral of cosine of ln of x dx. Well, when I was solving this integral, I was trying to apply the substitution method. I thought we can use u, say, or some y as ln of x, then dy would be 1 over x times dx, right? But it doesn't give anything there because we cannot then write, okay, we will write cosine of y, but as for dx, we cannot write this in terms of dy only. We will have x times dy, which does not work. Or we should have something that cancels out 1 over x, like dx, this expression. So I was thinking a lot, and after some time I realized that the derivative of ln of x is actually 1 over x, right? So we can make use of it somehow. And there is a trick which we'll use here. You can note that we can write this integral, this expression inside an integral, as cosine of ln of x times 1 dx, right? It does not change a lot, but now we can apply integration by parts. So we'll take cosine of ln of x and 1 times dx. So in our case, we have u as, well, of course I'll take cosine of ln of x as the function will differentiate, because we cannot find just directly its antiderivative. So it's wise to use it as function u. Cosine of ln of x, and dv we take as 1 times dx. So from here du will be, well, sine of ln of x with the sign of minus and times 1 over x, right? It's like this. And dv is 1 times dx, so v will be, v is x. Alright, now we can apply integration by parts, which has the form u times v minus v times du. So for our expression, it will be x times cosine of ln of x minus an integral of, well, we have now minus sine of ln of x times 1 over x multiplied by x inside. So I propose writing minus here, so it will turn to a plus. Like here we have minus here as well. So I'm directly writing plus to avoid some confusion or whatsoever. So we'll have inside sine of ln of x times 1 over x times x dx. I hope everything is clear up to this point. So we can rewrite this as x times cosine of ln of x plus, well, here obviously this cancels out, so we'll have sine of ln of x dx. Now I believe experienced ones, they already got the idea that if you have sine of ln of x, this is the same structure as cosine of ln of x up to the differentiation. So we can apply the same process, and we'll get again something with an integral of cosine of ln of x, and then we'll have like some things here. Also, the integral we want to find is actually itself a cosine of ln of x, so we can put cosine, like this expression, to the left side, or just subtract from both sides, and divide this expression by 2 to get the answer we want. So we'll basically write this as some, say, I don't know, variable a, and we'll search for a later on. Alright, keeping that in mind, we can just apply the same thing that we did before. We have x times cosine of ln of x plus, now as of integral of sine of ln of x, we'll deal with integration by parts one more time. This time though, I want to skip the part with this notation, du and dv, and write directly the result of this integral. So just keep in mind that we have sine of ln of x and 1 times dx. So the sine function is the function that we want to find the derivative of, and dx, like 1, is the function that we want to find an entire derivative of. So first we just, as we did in our previous videos, we'll use nothing special but integration by parts, but in our minds. So we have sine of ln of x, we just rewrite this, sine of ln of x, and we multiply this by antiderivative of dx, which is x, like antiderivative of 1. Then we subtract an integral of the thing that we found, the antiderivative, times the derivative of this function, sine of ln of x. And derivative of this function is what? It's cosine of ln of x over x. Like, since it's a composite function, I don't remember if I mentioned this earlier, to find its derivative, we need to write first, like, it's cosine of something that's inside, and multiply this by the function itself, which is inside, and its derivative will be 1 over x. Alright, so, and dx. Now we have an expression of x times cosine of ln of x plus x times sine of ln of x minus, like, x's they cancel out, an integral of x times cosine of ln of x. So our prediction is right. We have this, sorry, it's just cosine of ln of x. Yeah, our prediction is right. We have the same, we obtained this in the end. So now, to give you a sight of what's going on here, we have, well, this expression on the right side, and this whole expression is equal to this one. So we can just add an integral of cosine of ln x to both sides, and here it is. I'll write this as a remark, sides. Now we obtain, like, if we add this expression to both sides of the equation, we can obtain 2 times an integral of cosine of ln of x dx is equal to x times cosine of ln of x plus x times sine of ln of x. Now the integral which was desired is just the expression on the right divided by 2, and in the end we'll add some constant. So in the end, cosine of ln of x dx will be x times cosine of ln of x plus x times sine of ln of x over 2 and plus some constant c. It's important, we could add it here or wherever you want, but in the end it should be there. Alright, it's our final answer. I think we can even do like this. If you have some questions on this integral, which just required some tricky thing to notice, that each expression we can write as that expression multiplied by 1, and this is the thing that appears a lot, I think, in integrals. So if you see an integral, you just try integration by parts, substitution, also integration by parts, considering that expression times 1. Alright, I think it's enough. So see you on the next videos. Bye.